Welcome back again to my channel. I'm Felicitas Chenge. I promised you yesterday that I'm going to do a video on solving simultaneous equations using the matrix method, right? So I'm going to put up a pair of simultaneous equations up there, right? We have 2x plus 3y is equal to 6. That's equation 1. And 5x plus y is equal to 2. This is the same equation that we did yesterday, that we did in the previous video, right? So to solve using the matrix method, there are some important points to take note, right? When multiplying a matrix by its inverse, right? You are multiplying maybe matrix A by its inverse. We get an identity matrix. So for any matrix, if you multiply a matrix by its inverse, we are going to get an identity matrix. Either way, pre-multiplying or post-multiplying, A inverse times A, it's an identity matrix. Then if we multiply an identity matrix by any other matrix, this is the first point to take note of. The second point, an identity matrix times matrix maybe xy, let me use A, B, C, D. What do we get? We get that same matrix A, B, C, D. We multiply an identity matrix by A, B, C, D, we get A, B, C, D. That's the same again if we multiply identity matrix by maybe A, B. This is a 2 by 1 matrix. This is a 2 by 2. This is a 2 by 1 matrix, right? So identity matrix times this matrix, we get that same matrix, right? So we should take note of these 2 points when solving our simultaneous equations using the matrix method, right? I will remind you of those important points, right? For this pair of simultaneous equations, we are going to form a matrix, right? This is in terms of x, in terms of y, and on the other side we have constants, right? Terms without x and y, terms without any variable, right? So we are starting with the x variable, y variable, and terms without any variable. So we are going to formulate in a matrix using the coefficient of x 2, the coefficient of y 3, the coefficient of x 5, the coefficient of y it's 1, right? That's our 2 by 2 matrix. Then the second matrix, we are multiplying by our variables, our 2 variables. We start with the first variable, which is x, then y, is equal to the 2 constants, 6, 2, right? So we are multiplying this by this to get this, right? Then we want to find the inverse of this matrix, right? We want to move this matrix to this other side. So it's just the same as dividing by this matrix. So dividing by this matrix is just the same as multiplying by its inverse. We are pre-multiplying by its inverse. So we want to find the inverse there. Right, the inverse of 2, 3, 5, 1. To find the inverse of this, we first find the determinant. What is the determinant? The determinant is 2 times 1 minus 3 times 5. This times this minus this times this. Right? So it's 2 times 1, we are getting 2, minus 3 times 5, 15. Then 2 minus 15 is negative 13. Right, so our inverse is equal to 1 over the determinant. So it's 1 over the determinant, which is negative 13. So our negative, we put our negative on the numerator there. Then we multiply by this matrix, but this matrix, we have these two elements, they interchange, and they interchange their positions. And these two elements, they multiply by a negative, right? So we are going to have 1 there and 2 there. Then we multiply by a negative, it's negative 3. By a negative, it's negative 5. So the inverse is negative 1 over 13 times this. So we are going to pre-multiply by the inverse on this side and pre-multiply by the inverse on this side. Right? So I'm going to erase this part after multiplying. Right? So we are pre-multiplying by negative 1 over 13 multiplied by 1, negative 3, negative 5, 2. Then 2, 3, 5, 1. X, y is equal to. Remember, I said we are pre-multiplying by the inverse both sides. So that other side we have multiplied by the inverse. Now we are pre-multiplying by that same inverse, minus 1 over 13 times 1 minus 3, negative 5, 2 multiplied by 6, 2. Right. Remember, when I gave you points to note, I said if we multiply a matrix by its inverse, this is our matrix and this is its inverse. We are multiplying these two. If we multiply these two, we should get an identity matrix, right? So to multiply this by this, we are going to get our identity matrix 1, 0, 0, 1. That's our 2 by 2 identity matrix, right? Times x, y is equal to negative 1 over 13. We can simplify this part, multiplying these two matrices. So it's row by column. 1 by 6, it's 6, plus negative 3 times 2, it's negative 6, right? Then we multiply row by column. Negative 5 times 6, it's negative 30, plus 2 times 2, it's 4. Right? I'm going to erase the first part there. And I will copy this statement. 1, 0, 0, 1 multiplied by x, y is equal to negative 1 over 13 multiplied by, we can simplify 6 plus minus 6, this positive and the negative, we get a negative, right? So 6 minus 6, it's 0, negative 30 plus 4, it's negative 26, right? So we are done with this part. Right. multiplying an identity by any other matrix. We are multiplying this identity by this matrix. We get that same matrix x, y is equal to negative 1 over 13 times 0, negative 26. Right, so our x, y is equal to negative 1 over 13 times 0, it becomes 0. And negative 1 over 13 times negative 26, this negative and this negative become positive, and 13, 1 into this 2. So it's 2 there. Then we have our x, y being equal to 0, 2. So x is equal to 0, y is equal to 2. Therefore, x is equal to 0 and y is equal to 2. We are done with our pair of simultaneous equations. So I want you to follow the steps. First, let me have a summary of what we've done. First of all, we are going to form a 2 by 2 matrix. Let's say we have our matrix 3x plus y is equal to 16 and 2x minus 2y is equal to 8, right? We are going to form a 2 by 2 matrix. Remember the coefficients 3, 1, 2, negative 2, and multiply by our unknowns x, y. This should be equal to 16, 8. Then the second step, you are going to find the inverse of this matrix, right? So to find the inverse of this matrix, you should first find the determinant. Then after finding the determinant, we are going to multiply 1 over the determinant times, you interchange these two interchange their positions, right? And we multiply by negative, right? So you are done with your inverse. Then you pre-multiply by the inverse both sides. So you are pre-multiplying by the inverse, pre-multiplying by the inverse, right? Then the inverse times a matrix times its inverse, we get an identity matrix. So we have an identity times this matrix is equal to, you simplify that inverse times this, you are simplifying step by step, right? So the identity matrix times xy, we get xy, right, is equal to, you simplify this other part. So I want you to find the solution set. I want you to find the value of x and the value of y for this pair of simultaneous equation using the matrix method. Thank you.